All right, good afternoon, everybody. And this is the only way to be sure, obtaining and detecting domain persistence. So a bit about me. I'm Grant Bugher, and I've been hacking and coding and working on security since the 90s, which I know is old by DEF CON terms. I've been working in InfoSec for the last 10 years, and I'm very much a security generalist. I've been a dev, a tester, a program manager, a security engineer, an architect, a consultant, an educator, a little bit of everything, and have worked across dev tools, web applications, desktop apps, high security services for governments, application security consulting, etc. So I'm currently a security engineer for a big company. They are not sponsoring this talk though, so I'm just giving this as an individual. I also run Perimeter Grid, which is my security blog and consulting service. I've spoken before at BlackHat, at DEF CON 22, and at ThoughtCon, and have been coming to DEF CON for, I guess, 7 years now. So, with that, and the usual disclaimer of this is my own talk, it does not necessarily represent the opinions of my employer, we can get started. So, you have a domain controller. And if you have a domain controller, you probably have some kind of monitoring on it. But the sad fact is the state of monitoring in real enterprises is generally woeful. Most companies I've seen, it's really bad. There's local event logs with default configuration, and if there is a seam, it's designed for compliance, not for security and forensics. It collects the PCI mandated events, and nobody ever tunes it, and nobody ever reviews it. And that sort of monitoring is not going to be able to find somebody in your domain. So for the demos here, we're going to assume that you've got basic monitoring. You've got detailed granular auditing enabled in group policy. You've got event logs that are being pushed or pulled to a seam off the servers, ideally inaccessible to them. You've got centralized HIDs or anti-malware logs. And you've got process start command line logging and PowerShell auditing enabled in group policy. That last one does require at least relatively modern versions of Windows and not XP or some such. So I've set up a demonstration domain to be able to walk through the attacks and defenses. And I set it up as a Windows Azure virtual network. It's got 3 servers and a workstation, a domain controller, a web server, a Splunk enterprise server, and a workstation used by the hapless attachment clicker Bobbert, who is going to be running our Trojans. Splunk Enterprise is configured to run as a domain user. So it has domain credentials. It pulls non-domain controller logs via WMI. And the domain controllers, however, push their logs via Splunk Universal Forwarder because otherwise the monitoring account would have to be a domain admin, and I don't want to make this too easy for myself. Finally, there is semantic endpoint monitoring on systems forwarding to Splunk via event log. Meanwhile, on the other side, so you want a domain controller. Well, there are lots of ways to get access to a domain, and they're pretty much limitless. You could exploit unpatched servers, get an admin's password with a keylogger, get an admin to click on your malware, steal an AD backup, exploit security software or somebody who is running their SIEM as domain admin, use your 0 days that I'm sure you have a large pile of. But this isn't what this talk is about. On the bright side, this is a DEF CON. There are a lot of other talks about gaining access. This is about what do you do once you've gained access to make sure that you keep it. So we're just going to stipulate that you've momentarily compromised the domain. You've got TCP/IP network access. Maybe you've got a pwn plug or a compromised device inside, or a beef session to a workstation, whatever. And you've obtained domain admin. You've got a interpreter session with domain admin. Doesn't really matter where you got it. The administrators are at some point going to notice you've compromised their domain and try to remediate and kick you out. And then they're going to try to figure out what you did. So it's going to be kind of a red team, blue team type of demo. Our goal is to make it easy to get user access and then elevate that access to domain admin again, using only the TCP network access that we have. Meanwhile, their goal is to figure out what we did and how to kick us out without having to wipe everything and start over. So, okay, we've got this domain admin token. What can we do with it to make sure that we can always get domain admin again? Well, I guess we could create a domain admin account. You might also try banging a gong. This is about the least subtle thing you could do. But that's okay. I have videoed my demos because I know the demo gods are never kind at DEF CON. All right, so I'm going to start up Metasploit, set up a handler for my Trojan that I've got my domain admin session on. I'm using Meterpreter reverse HTTPS, which is my favorite one because outgoing HTTPS sessions to 443 are the least suspicious thing there is. And I will connect to my Meterpreter shell. From there, if I've got a domain admin token, it's simple enough. I can drop to my shell, and I can create an account for Frederick Nord, Fnord, in honor of DEF CON 23, and add this domain user. Once I've added him, and I can do this anywhere. I don't have to be on the domain controller. I'll just add him to domain admins. So what's this look like to our Splunk session? We have a lot of events. We have a 4720, which is a user account was created. We see here that the admin account created a new account called Fnord. 4722, they have enabled a user account. This immediately follows creation. 4724, they have reset an account's password. Also immediately follows user creation. And most suspicious of all, we get a 4728 event, which is a member was added to a security-enabled global group, in this case, domain admins. You can pretty much count on if an enterprise is monitoring anything, this is probably one of the events they monitor for. It's almost always administrative action. It's very seldom done by an automated process. And adding users to domain admins is about the most suspicious thing you can do. So it also creates a security-enabled global group, which is 4737 as well. So we're going to look at what are the much more subtle things we can do to make sure we can get access again without having to actually add ourselves to the domain admins group. First of all, we're going to need to make sure we can at least get user access again. And for this, we need some kind of auto-running malware on a system we've targeted. So in this case, I'm using this PG workstation system that somebody logs into. Now, everybody knows about the registry key current user Windows current version run, which automatically starts things as soon as people log in. But what a lot of people don't realize is that is pretty far from being the only one. I'm going to pull this up locally instead of using the video. All right. So here we have a wonderful little sysinternals tool called autoruns. And the autoruns tool shows you various things on the computer which are set to automatically run at boot up and login. So at logon, we've got, let's see, it's still running and collecting stuff. So logon is going to contain our usual Windows current version run. But that's far from the only thing it will contain. Sorry, I can't see my own screen here. So we've got components running from a wide variety of locations. Any of these apps that you can replace can then run automatically at login. In addition, Explorer has shell handlers. Internet Explorer has browser helper objects that load as soon as anybody starts up the browser. We also have scheduled tasks. Now in this case, these are interesting. Anytime you get a scheduled task listed in red here, I didn't run this as admin, which is the reason I don't have nearly as many auto runs as I would normally have, so I'm going to rerun it. Anytime we get one of those entries in red, it indicates that the auto run is running unsigned code. In this case, many times it is VB script code. Okay, I'm going to change this so I can see my own screen. That did not work at all. I still can't see my own screen. All right. So, getting back to here. So I've got context menu handlers. I've got my scheduled tasks. Any of these things that are VBS files are particularly good because they're unsigned code. I don't have to create a new file on the machine. I can just add a line to the VBS that runs whatever my Trojan is. There are also servers, drivers, one of the more interesting ones, image hijacks. I don't have any running on this system right now. We'll get to both image hijacks and LSA providers a little later as some of the more interesting things you can use. There we go. I'm going to unhide Microsoft entries. So like here's an example of when IE runs, it will actually run, it has, or rather when a HTML file is run, it will hijack that, send it to IE. It's part of how IE runs. But I can add an image hijack so that when someone runs any exe of my choice, it will also run my own executable. So this is also very useful as a forensics tool because you can go over here to everything and see all of these red entries. There are also yellow entries, which are places where my system is set to run a file which doesn't exist. So I can add a file to any of those, and whatever it is, it's going to automatically run. No one's going to notice I've added something that's not supposed to be there because I didn't tell it to auto-run. It was already trying to auto-run that item. So there are a great number of places that you can add these auto-running programs. All right, let me get my slides back up on the screen. All right. So another place I can put my backdoors, though, if I don't want to drop a file on the machine at all where it could be detected by forensic examiners, I can drop it directly into the registry. So in this case, I'm going to be using Veil Framework, which is a great little obfuscator of backdoors, to create a PowerShell-based version of my remote access Trojan. So I'm starting out PowerShell, shellcode inject, download virtual, which is a very small bit of PowerShell, which simply pulls down a larger piece, which then builds an interpreter shell directly in memory and runs it without ever actually touching disk. So I'm going to generate my shellcode in Veil, once again using interpreter reverse HTTPS, as I usually do. And this is going to create a few pieces of PowerShell. It's going to create a very short initial downloader, and then a longer file, which is the actual payload, which is placed in a file that I have to place on my own web server. So it takes a little time for it to generate. I call it psreg. So you can see it generated a payload file, psreg.txt, as well as a handler file, and secondary payload written out to output source this long random string of letters. And this needs to be served up on the server that I specified. So I'll X out of Veil. And copy my randomly named file. If I wanted to, I could, put this on an actual publicly accessible server, give it a perfectly innocuous name that wouldn't look at all unusual in web logs. It can be called whatever I want. Then I've got this psreg.txt, which has the very short PowerShell command, which will download that payload and execute it in memory. Now, it is by default in Veil, it's bin hex encoded, base64 encoded rather. For this, I actually had to decode it because it turns out in the image hijacks registry, there is a relatively short command line length allowed, and if you put this entire long encoded thing in there, it has a hard time actually running it. All right. So, oops. Okay, that's the same one. Okay. All right, so I'm going to connect my user session here. And I'm going to create a registry key in this user session. And in this case, I'm going to be modifying the image file execution options for calc.exe. Really, I would modify them for something that's in those auto runs or something that I would expect my administrator to frequently run. Preferably, I find something in auto runs that I don't actually care about, nobody really cares about. People always have printer drivers and video drivers that have to have some memory resident component. Nobody's sure what they're supposed to do anyway. There are a dozen of them. You can easily hijack any of those. So I'm adding an image file execution option called debugger, which has my PowerShell in a hidden window, bypass execution, and it's going to do an inline execute of what it downloads from this URL that I've provided there. So when that runs in PowerShell, it will download that with basically the PowerShell equivalent of wget into memory and execute that PowerShell. And that secondary payload is my Meterpreter virtual inject. So now my end user goes and runs the compromised app. In this case, they're going to run calc.exe, and it immediately disappears. So this is why you want to use something in the startup that no one's going to care about anyway. If you really wanted to get fancy with it, you could develop your own script which would actually run the necessary target. The problem is you can't just invoke the exe directly in the normal fashion, because if you do, the image file execution options will just hijack that one again and run your PowerShell. So you'll just create an infinite loop. So you have to actually script it to take itself back out of the registry. And as soon as they ran calc.exe, from my perspective, running the handler, I immediately get well, I've got a video of it, but it connects to me with the Meterpreter shell. It does exactly the same thing as any of the other Trojans does, but it does it entirely in PowerShell with no need to drop anything on the disk to be later found. So at that point, I've got user access again. But I don't have domain access, and I want to have my domain admin session. So what can I do on the domain controller to make sure that I'm always able to elevate to domain admin? And we've got at least 4 options here that are more subtle than adding yourself to the domain admins group. So the first one I'm going to go over is the skeleton key patch. Now this was actually presented at DEF CON a couple of years ago. And it is now a built-in feature of Mimikatz. Unfortunately, it's not a built-in feature of the Kiwi module of Meterpreter yet. So we have to use the actual Mimikatz exe in order to run it. The other option would be to use something other than Metasploit. I know like PowerShell Empire, for instance, does have the skeleton key patch in there, so you wouldn't have to drop Mimikatz on the disk. In this case, I've killed the antivirus process so that I can proceed to drop Mimikatz on the disk. Once again, that's not very subtle. It will leave an event. But if you were using a different remote access package rather than Meterpreter, you could manage to do this without necessarily hitting disk with it. So I create my shell. I run Mimikatz. And I grab debug privileges. And then I run the MISC skeleton module. And this does a quick little patch to LSASS. If you recall earlier in auto runs, there was a section for LSA security providers. Well, what we've just done is we've added an LSA security provider. And we have added the Mimikatz security provider. And what this actually does is now next time I connect to my workstation, I'm an unprivileged user. I'm connecting to a session as Bobbert again. I don't have any user privileges, so if I get my UID, I am just Bobbert. And if I go to my shell and I try to connect to the domain controller's C drive, I'm going to get an access denied because Bobbert does not have access to the administrative shares on a domain controller. Drop all of my connections, and now I'm going to net use it, only this time I'm going to specify I am the domain admin user, who is pgdefcon whack admin. And my password is Mimikatz. The domain admin's password very much is not Mimikatz. However, the fact that I have added that LSA security provider means that Mimikatz is a valid password for everyone in the domain. I can log in as anybody anywhere using that password. And so I am still Bobbert if I do a who am I, but I'm able to do anything that the domain administrator can do. So assuming you don't disable the AV and drop Mimikatz on the disk, the only unusual event you're going to get from this is a privileged service was called, event 4673, sensitive privilege use. And we see here there was an LSA register logon process. And the unfortunate thing about these events is they're not super rare. You're going to see this anytime a DC reboots anyway. So you could monitor for them at unusual times, such as when you don't have a DC rebooting. If you've got one domain controller, that's probably not terribly hard. If you have 150 of them, that may be terribly hard. So other things that we can do. One of these is probably the most interesting of the common AD exploits, which is creating Kerberos golden tickets. This is another one that was first presented at DEF CON, I believe, 3 years ago. It is, luckily for attackers and unfortunately for defenders, very difficult to centrally remediate. In other words, this isn't a vulnerability somebody can patch. And so golden tickets are Kerberos tickets that the attacker can create themselves rather than relying on the domain controller to create them. So in this case, I've got my compromised domain controller, and I'm going to, once again, connect to it with my interpreter shell. All right. Let that start up. Got my session. Now, I'm a domain admin, but it turns out that, and first thing I'm going to do is I'm going to get my SID, because my SID is the domain SID followed by the user SID. So I actually need the domain SID for this. Now, I'm going to grab the list of processes and migrate myself into CSRSS. With golden tickets, to get the hash I need, I have to be in a process that is actually started as NT authority system. So I can't just get system privileges. I need to migrate into a process that started that way. I'm going to load Mimikatz extension again and dump hashes. Well as all the user hashes here, I have this one, which belongs to, I grabbed the hash of that, it belongs to an account called KRBTGT. This isn't a real user. This is the Kerberos ticket granting ticket hash. This is what's used by the domain controller to sign ticket granting tickets in Kerberos. Now, Mimikatz has an extension, golden ticket create, and I'm going to run that, and I'm going to specify the domain, PG DEF CON, and I'm going to specify that I want a ticket that belongs to groups 501 and 502, so it's a domain admin, and I'm going to specify that KRBTGT hash that I just copied above. I also have to specify the domain SID, which is why I grabbed that a little earlier. And I'll specify a path for storing this. I'm going to call it pgdefcon.golden.tkt so I can remember it. And I'm going to specify the user admin. Now, the user I specify doesn't actually have to be a member of any of the groups I specify. I can create a ticket that says some other user is domain admin. It doesn't matter. The ticket is going to specify what groups it has, and the other servers are going to believe me. Now that I've got that created, what do I do with it? Well, later on, I'm now connecting back to my workstation as Bugher again, so I'm an unprivileged user. So I'm Bugher, I have my normal user SID, I load up the Kiwi extension again, which is Mimikatz 2, and use Kerberos ticket list and see, okay, I don't have any Kerberos tickets right now. And so naturally, if I drop out to a shell and attempt to net use on the domain controller, I get password is invalid. But I can then, in interpreter, go ahead and call up that golden ticket file that I saved earlier. So I'm going to do Kerberos ticket use pgdefcon.golden.tkt. Using Kerberos ticket stored, ticket applied successfully, I'm still Bugher if I do a get UID. But now, if I shell out and do any kind of network access, that Kerberos ticket is presented. So I can net use the domain controller's admin partition and list things. It doesn't matter that I am not actually a domain admin or a member of any of those groups, because that ticket I created specified it's in the domain admin group. I can do anything someone in the domain admin group can do. The other great thing about Kerberos tickets is, first of all, if they're less than 20 minutes old, it doesn't even check with the domain controller to see if it should use the groups. That is one thing. If the ticket is more than 20 minutes old, the user you're impersonating will actually use their actual current privileges. But if you create a new ticket that's very young, then it's fine. It doesn't matter if the privileges you specified are totally unlike what that user actually has. It will still just use whatever's in the ticket. So what does this look like as a defender? Well, creating a golden ticket doesn't look like anything because all I did was dump hashes straight out of memory. I could create the golden ticket on my own computer. I don't have to do that on the domain controller. Once I've got the hash and the domain SID, I can do that locally without creating any events anywhere. And I can do it for any user I want, for any groups that I want. Now, when I go to use it, it varies what you see. Here we have a couple of login events. They're both an account was successfully logged on. One of these was a legit admin logon, and the other was me using a golden ticket. You'll note they look basically identical. In this case, the only difference we have is that in one of them, the account domain is in lowercase, and in the other one, the account domain is in capital letters. And that's not necessarily an artifact of using a golden ticket. That's an artifact of when I ran the create golden ticket command, I typed the domain name in lowercase. And so it just took exactly what I put in. All you're going to see is potentially anomalous login events, and they're going to be anomalous in different ways. Maybe you see an FQDN where you expect a NetBIOS name. Maybe you see a NetBIOS name where you expect an FQDN, casing issues, that sort of thing. But there is not a consistent indicator that somebody's using a golden ticket. It's actually relatively hard to detect. It's mostly a matter of if people have access they should not have, and are gaining access to things without actually being members of groups, it's something to suspect. That's probably the worst thing about the golden tickets. The other thing that's terrible about them is, so you find out an attacker does have a golden ticket, what do you do about it? You have to rotate the hash of that KRBTGT account, and you have to do it twice because it actually keeps a history. So the password that's one password old still works. If you are running Windows Server 2012 domains, this is actually not terrible. You rotate that account twice, and now you can go on about your business and hope your attacker does not still have current access and can just generate a new golden ticket. If you are running a Windows 2008 release or older domain, it is a much bigger pain because as soon as you rotate those KRBTGT passwords, nothing in the domain will be able to authenticate until it reboots. And that also means you can't authenticate to it to tell it to reboot. So it is a pretty messy challenge of scripting and remediation, which is why until pretty recently, now people are starting to run on 2008 R2 or 2012 domains, sometimes the response to an attacker having a golden ticket was to just kind of put up with them and not to actually remediate it entirely or hope they don't have one. So it's a reason to be on a domain with a later functional. That's the other thing. You not only need to be running 2008 R2 or later, you need to be running a domain functional level of 2008 R2 or later. Just upgrading a domain controller does not necessarily upgrade the domain functional level to a current version. That's an explicit decision by the domain admin. So that's another thing we've got, but we actually have a couple more. So another thing we can do is tampering with SID history. So now we're getting into some Windows AD features that most sysadmins probably have never used and are not necessarily very aware of. So SID history is a feature of AD that's designed for domain migration. It's designed for I'm adding a new domain to my forest, and that domain was, say, another company acquisition, and I need users in my new domain to still be able to do stuff on machines joined to the old domain, but I don't want them logging into the old domain to make migration easier. And what it lets you do is add secondary SIDs to a user. So the user not only has their real SID, they've got other SIDs that they act as. So this is another one where I actually need real Mimikatz, and since I'm using Metasploit, that means killing the AV and uploading a copy of Mimikatz again. So I'm going to get my user ID. So here's my admin session. And let's move over into a process started a system. All right, drop onto a folder I have Mimikatz in. And I'm just going to run, it's very simple. The command is just add SID. So I'm going to do misc add SID, and I'm going to add to Bobbert, the SID, enterprise admins. I could choose a group SID, I could choose a user SID, I could choose a computer account SID if I really wanted to. Whatever I want to, that SID is now added, and Bobbert is equivalent to whatever the privileges that SID has. So what's this actually look like to Bobbert? It actually looks kind of weird because there is no overt sign that they have secondary SIDs. In this case, I'm firing up Active Directory using computers, pull up Bobbert, and I look in the groups that he's in, and he's not in Enterprise Admins. If I pull up Enterprise Admins and look at members, he's not a member of Enterprise Admins. There's no particular sign that he's a member of that group. But note that the add and remove buttons are not grayed out. Just because I'm not a member of Enterprise Admins doesn't mean I don't still have full privileges to edit it. Now, once again, you wouldn't want to actually go adding users to the group until you were ready to do some sort of exploit, because that clearly is going to be creating events. But this is just a demonstration of the fact that he's got the full privileges of Enterprise Admins, despite not being a member of that group, and can do anything that EA can do. So what does this look like? This is one of the relatively easier things to detect if someone is actively looking for it. Because in Event 4765, SID history was added to an account, which you're never going to see except during explicit administrative action. And it says exactly what security ID that I added to that account. The problem is, once again, a lot of people are not configuring their SIEM and actually watching actively for events. And we're not seeing the super common events like, security group membership changed. You'd have to be looking for a SID history change. All right, so others we've got is tampering with Active Directory DACLs. Now we're getting into some even weirder stuff. Active Directory objects actually all have access control lists on them, just like files do. And those objects, I'm going to unplug my network here. Those objects are not easily visible to the user. They're not really exposed in the UI anywhere. And most Windows sysadmins use the UI, and that's kind of what Windows is for, is providing user interfaces to everything. So because these are not exposed in the UI anywhere, I actually have to use a piece of VB script to do this. So in this case, you could obviously use C script or any other script you wanted to use, but you need something that'll run in Windows scripting host. So in this case, I've got a script that is going to join Bobbert to the built-in group terminal server license servers. It could be any built-in group. I just want a built-in group that's there on every machine and that nobody really does anything with. So I'm going to be joining that account to there, and then I'm going to be modifying the ACLs on that on both that object and another object called admin SD holder, which is found in Active Directory. I'm not expecting anybody to read the script. I just wanted to have it in the slides, so if you download the slides, you can actually see the exact script being used. So admin SD holder is kind of an interesting object. Windows file protection tries to protect Active Directory objects from having their ACLs tampered with. So if I were to just change the ACL on domain admins and say Bobbert can access it, within an hour, Windows would discover that ACL had been tampered and will immediately stomp over it with the standard administrative object ACL template, admin SD holder. So instead, I'm just going to modify admin SD holder and have Windows stomp that onto all the AD objects for me. And so when I modify that ACL, it has some rather unusual results. It's actually a lot like, it looks a lot like the SID history does. Once I've got that, if I look at my groups, domain admins, once again, doesn't have Bobbert in it, and Bobbert doesn't have any access to go adding and removing to it. So now I'm going to connect to my administrative session, and I'm going to upload my VBS file. And once I've got a shell, I'm going to go ahead and run that VBS file. It takes a few seconds, makes a bunch of LDAP calls. All right, now I just delete my script, and Active Directory has a backdoor in it. So, going back here, I'm still Bobbert. and if I go to domain admins, I still don't really have access there. However, nobody really monitors local built-ins like terminal server license servers. And even though I'm not a member of that and I'm not an admin, it turns out I do have the ability to edit that. And if I do edit it, now I can go back to domain admins, and I have add and remove access. So I've just granted myself the ability to have domain administrative privileges without needing to modify anything except a local built-in that is not normally something that's monitored. And now I've got full access to whatever I wanted to. So what's this look like in our event log? Well, we do have a security-enabled local group was changed if you're monitoring security-enabled local groups. It's an event 4735. It's changed to terminal server license servers. It's not the most common event, but neither does it really jump out to you as a serious security event. Normally that would be, oh, somebody added a terminal server license server. But we do have a security-enabled global group was changed. It didn't note that it doesn't say we added or removed members. It doesn't say specifically what we did, just that there was a change. And then we get these very weird events. This is a 5136 directory service changes. Once again, not necessarily something a lot of people audit. A directory service object was modified, and we get one event like this, and it says the type is value deleted on our domain admins, and then another event like this that's value added. I went ahead and highlighted the only difference in that massive block of GUIDs. Because once again, it's not necessarily super obvious what has changed. If somebody's not even aware that Active Directory objects have DACLs, it's not going to be obvious what this means. This can easily be the sort of event that looks like, well, it's a little suspicious, something happened. The other thing is it's not at all obvious what they should do about it. You see these events, how do you change the DACL back? It's not exposed in the UI. You'd have to script it. We also have this other one, which is the admin SD holder. The admin SD holder object. And once again, it's the same ACL change. Admin SD holder means if someone does change the ACL back on domain admins, Windows will just stomp it with the compromised ACL again within an hour. So Windows will helpfully put your backdoor back. So those are some of the ways an attacker can use to create themselves backdoors in Active Directory that are not necessarily obvious to the defenders. So what can we do for detection and remediation? Well, the good news is everything that I listed here does leave traces in the event log or in the AD change log. None of this is 100% invisible. The closest thing to that is actually golden tickets, which leave very little trace whatsoever. And their counterpart, silver tickets, which I didn't go into, which basically are the same thing, only they only allow you access to a specific service. But if that specific service is something with administrative privileges, you can potentially elevate right back up using that service. Those are very difficult to detect at all. But the rest are easy to detect, assuming you have the correct policies set. The problem we run into is, well, I didn't specifically go through it, an attacker can disable event retrieval and forwarding and purge the event log. If an attacker really doesn't want to leave events showing exactly what they did, they can kill the Splunk Universal Forwarder. They can clear the event log. And there's not really anything you can do about that. On the other hand, it does leave a very obvious event. The event log was cleared is an obvious security relevant event. It's another one of those things like changing the membership of the domain admin group that sends up a big red flag that somebody's doing something bad. The problem is it doesn't really send up much of a flag of what exactly they were doing, which can make it very difficult to remediate it. And also, yeah, it kind of sucks when somebody turns off logging on the domain controller, because then you're blind to what's going on for a short period of time. Of course, you also need to change compromised passwords when you know somebody has compromised something. But if somebody's compromised the domain, they probably have a copy of ntds.dit. So you not only need the passwords they compromised to be changed, but really every password in the domain. Even service accounts, which are usually not something people want to change the passwords of, and even the Kerberos ticket granting ticket. You'd also need to do a full audit of every AD change since the compromise for things like group membership and SID history changes if logging was disabled, because they could have, they could have put a chain of SID histories through any number of items. Now, there are AD forensics tools that will let you diff AD against a backup and find out everything that's been changed since that time. But once again, it's possible for the defender to root that out. It's just potentially a great deal of work, a lot more work than the attacker had to put into it. Also, you need your audit stuff configured correctly. For all of this demo, to catch all those events I caught, in audit policy, I had it set to audit account logon events, account management, DS events, logon events, object access, policy change, privilege use, and system events. Object access and logon events are extremely large volume. Especially logon events includes all network process executions. So every time my monitoring server wants to connect and pull logs, which it does every minute or every 10 minutes, I've got another logon event on every server in my domain. So they can create a lot of volume. I also went into advanced audit configuration and added computer account management, security group management, and user account management. In detailed tracking, you can also audit RPC events and process creation. Audit process creation is actually very powerful for finding out what people did, especially if you also turn on the setting to do command line logging, because then you get every command they typed into a shell. You also get every command they typed into PowerShell. So some of these in-memory PowerShell exploits, which otherwise leave no trace on the disk, can be creating a lot of events if you've got that logging turned on. The problem there, once again, is auditing process creation creates a very large number of events, especially on a domain controller. Processes start and stop all the time, and it's totally innocuous. So it's one of those, auditing process creation will give you a wealth of forensic information, but it's very hard to alert on it other than, auditing process creation for mimikatz.exe and things along that line, which hopefully in a real pen test or real intrusion, an attacker would know to rename the files at the very least. More likely, they're not going to just rename the files. They're going to run them through something like Veil Framework or Backdoor Factory and completely obfuscate them so that not only do they have a new name, they're not going to show up in anti-malware. Something extra you can do if you really want to be intensive on the logging is, you can do process start command line logging and PowerShell logging. And the sysinternals monitoring service, sysmon, can be installed on systems. This is a fun little tool. It not only does it do log process creation with command line, it logs the parent process, so you can tell what process spawned all of these. And it includes a process GUID, so you can easily correlate between processes with the same name. Includes a session GUID, includes all the DLLs that are loaded, and it gives you hashes for all of the DLLs and for the executables. So if someone has Trojan something with Backdoor Factory, you notice that the hash is different. You can even have it log all the network connections and do a full IP tables type log. The log volume on an active server running sysmon with everything on is pretty extensive. In fact, even without doing file system and registry monitoring, the log volume to really detect all of this is pretty insane. To capture all the logs in this presentation, my domain controller alone was producing 500 megs a day of logs without sysmon per day, per domain controller, while the network was idle and had no active users doing anything. So that's the kind of log volume we're talking about there, the gigabytes per server easily. So every system that has an attacker, that has ever had an attacker on it with administrative access or a wiped event log so that we can't necessarily track down what they do, needs to be entirely rebuilt. Your alternative is doing file system forensics, which could detect these changes. Honestly, that's probably even more work than rebuilding the domain controllers is. Under certain circumstances, it can certainly be worthwhile to do, but it's not viable as a standard event, a standard security incident response. So if you've had your logs disabled and you don't have a full AD change history or the time to go through all the events, you pretty much are down to nuke the entire site from orbit. It's the only way to be sure. You're down to rebuilding the domain, changing the hashes of everything, including the ticket granting ticket, and still, unless you're going to rebuild everything at the site, even the workstations, you probably still have someone who can get regular user access or has access to silver tickets. There's not much you can do to clean those out. So the other question is, well, is this a problem with Windows domains? And kind of, but it's really kind of a problem with complexity. You could probably find just as many interesting ways to backdoor Linux and other operating systems. They'd obviously be entirely different ways. But modern operating systems have an awful lot of stuff in them. And when you look through things that start hundreds of scripts at boot and do a lot of processes at login, there are simply too many places for an attacker to hide. This said, most of these you could detect with some decent event log monitoring. The biggest problem is most enterprises don't have decent event log monitoring. They're doing very little because the only way to get it involves manual work by security analysts, people actually sitting down and creating alerts and studying their environment and seeing what is actually normal behavior so they can detect anomalous behavior. Companies really like to buy security products that you just stick in a rack and walk away from. They don't like having to hire a bunch of analysts to do a bunch of work. And until they do, you end up with domain compromise being almost impossible to remediate. So I do have updated slides on my website. The slides that are on the DEF CON CD are pretty rudimentary because, of course, they don't have any of the demo videos. The DEF CON CD slides are PDFs, so none of the videos are there. So I did post my actual slides up on my site. There is not an actual post on the site. You'd have to go directly to the defcon23.pptx. Obviously, I'll update the site in the next few days, but have not yet done so. While I videoed the demos, I do have this virtual network still up and running, and so if anybody has any questions or needs anything demonstrated, let me know. And that's it. So.